Hi, we are group trio plus one. The code that we got for our unknown hormone project was 306. So we got with the controlled in the experimental data, we can see a lot of decrease. The ones that increased was the thyroid CPM, the testes, the plasma, and the glucose. So with the glucose, we can see that the experimental data did increase and was much more larger than the controlled. And then we can see with the significant differences from the information that we were given, the data, that the body weight gain and the thalamus both decrease. We can also see that the adrenals and the tibia width decreased as well. With the plasma-free fatty acids, we can see an increase. And then a little rundown, the body weight, the thalamus, the adrenals, and the tibia width decreased. And then the plasma-free fatty acids increase and the glucose increase as well.
These are the hormones we decided to eliminate it. TSH and thyroxine, there was little to no change with the thyroid data. And for the growth hormone, there was no significant body weight loss and the tibia weight actually decreased. For HCG, testosterone, and estradiol, it did not impact the reproductive system, and there was no significant data involved with the ovaries, testes, uterus, seminal vesicle, or prostate. And for the placebo, there was a clear focus area being impacted, and we can see that there are physical change which show that it is impossible to be a placebo. For ACTH, if there were high level of ACTH, we will see an increase in adrenal gland, but we saw a decrease instead. And these are the possible hormones. We kept glucocorticoid because it affects the bone, fat, liver, and muscle. And we see an increase in the free fatty acid level in the blood. So it can be a hormone to consider. Also, we see a decrease in thymus size, which is involved with the immune system, and glucocorticoids inhibits many of the immune function. It also decreased ACTH production, which will align with the decrease in adrenal gland size. And glucocorticoid also inhibit the amount of bone that can be made by osteoblasts, which decrease bone density, aligning with our findings of decreased tibia width. And we also keep epinephrine because blood sugar was elevated. And for somatostatin, it affected the regulatory system of the body, which are impacted by the data. And it's also the opposite effect of growth hormone.
So for our first test, we decided to take a look at the vital signs and the physical attributes of the control and experimental animals. So for the control data showed that the heart rate was at 110, respirations at 42, body temperature was 41 degrees Celsius, blood pressure was at 170 over 100. On the experimental side, the heart rate was at 127, respirations were at 51, body temperature was at 43.3 degrees Celsius, and the blood pressure was 207 over 121. So as I previously mentioned, the vital signs showed a significant increase in heart rate, respirations, body temperature, and blood pressure. So based on the results of the vital signs, we were able to conclude the elimination of the hormone somatostatin. Somatostatin is a hormone that usually reduces heart rate. And the results indicated and supported the possibility of the unknown hormone to be either epinephrine or glucocorticoid. Here are the physical attributes side to side of the control and the experimental. For the control side, the hair was fully covered and texture was normal. The sclera of the eyes were also normal. The skin texture and appearance were normal, and the limbs were of normal size and diameters. For the experimental side, the hair was rather thin and coarse, as well as brittle. The sclera was slightly bloodshot. Skin was rather thin and was able to bruise easily, and the limbs were thin and spindly. So based on the results of the vital signs and the physical attributes, we noticed that the experimental animal appeared to be under more stress in comparison to the control. Since the vital signs showed higher levels of stress, this led to the conclusion that the unknown hormone could um, potentially be glucocorticoids, as excessive levels can lead to the thinning and brittle hair, as well as easily bruised skin and bloodshot eyes. Excessive levels of glucocorticoids tend to suppress osteoblast activity, which results in thin and spindly limbs.
So the second test that we asked for was a plasma radioimmunoassay for glucocorticoid. We saw a control level of 3,544 CPM and an experimental level of 1,343 CPM. So we saw a small amount of radioactivity in the experimental data, which indicates a large amount of this hormone glucocorticoid. So the conclusion that we drew from this was that we can illuminate somatostatin and epinephrine. The third test that we asked for was a plasma RAA for somatostatin. We saw a control level of 1,311 CPM, an experimental level of 3,110 CPM. So we saw a large amount of radioactivity with the experimental data, which indicates a small amount of the hormone somatostatin. So the conclusion basically confirms our elimination of somatostatin. So from all the data provided to us, we can conclude that our hormone is glucocorticoid, and there are a couple reasons why. So we did see an increase in free fatty acid levels in the blood, which can indicate higher levels of glucocorticoids. Glucocorticoids also inhibit immune function, which is why we saw a decrease in thymus size. They also decrease ACTH production, which would explain the decrease in adrenal gland size. They inhibit osteoblast activity, which is why we saw a decrease in tibia width. And then glucocorticoids also tend to increase blood glucose levels. The vital signs did align with signs of stress. And lastly, the plasma RAA confirms high levels of glucocorticoids in the mice system. So overall, we can conclude that our hormone is glucocorticoid.